Welcome to Study Loop.
All right, hello. So today we are being asked to draw the important resonance structures for both of these compounds here. So we'll start with the NO2 plus. And once again, the first step is to draw the basic Lewis structure and then go from there and see if we can find any other important resonance structures by pushing electrons around. So as usual, first thing we do, we look at whichever one has the lower group number. In this case, that is going to be nitrogen. So we put nitrogen in the center. We can put our oxygens on either side. We draw this initial single bond, and then we count the total number of valence electrons. So we have 5 for nitrogen, and then 6 for each oxygen. So it's 2 times 6. So 5 plus 12, we have a total of 17. But you'll notice the plus sign here. That tells us that because we have a positive charge, we're going to need 1 less electron. So we'll have a total of 16. So we try to distribute those. So we have 4 in play already in the bonds, and then we will distribute them on oxygens first. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then you'll notice that we have a total of 8 here and a total of 8 here. So that completes our 16 electrons, but once again, nitrogen is kind of hanging on its own, and it's not an octet, so we need to form some double bonds. So we'll move 1 lone pair here, 1 lone pair here, and that will give us this structure. And we can see that we will have a total of 1, 2, 3, 4, 5, 6, 7, 8 here. 1, 2, 3, 4, 5, 6, 7, 8. That completes our 16. Now, in terms of drawing additional resonance structures, oh, and I forgot this because we do have a plus charge. So this is how you indicate when you have an ion. Going beyond this, now you may be asking, what are some possible resonance structures? Well, we could move one of these one of the double bond electrons back to a lone pair. So if we push this back onto oxygen, could that help? But then if we were to do that, what you'll see is we'll have, let's say, this oxygen now will now have a negative charge, and our nitrogen, having now missing one of those electrons from the single bond or part of the double bond, will now have a positive charge, and this we're assuming is the same. Now, the reason this is not going to be important is because for no apparent reason, what we've actually done is we've ended up giving nitrogen a positive charge and giving oxygen a negative charge, and that's not necessary. And therefore, this is not an important resonance structure because we are now giving formal charges. So we'll have a -1 charge here and a +1 charge here, and that's not necessary for us. So because of this idea, because of this situation happening, we just will stick to this structure alone as the important resonance structure, and this will not feature at all. Now over here, let's look at this molecule. Once again, we've tried to figure out our central atom first. That's going to be nitrogen once again. And then we can draw the 2 oxygens and the fluorine as such. We'll draw a single bond, count the number of valence electrons. So that's 5 plus 2 times 6 plus 7. So that's 5 plus 12, which is 17. 17 plus 7 gives us 24. So we start filling in the lone pairs. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That gives us 8, 8, and then 1, 2, 3, 4, 5, 6, 8 as well. So once again, we have 24 total. But the problem is, once again, nitrogen does not have the full octet, only has 6 electrons from the 3 single bonds. So we'll move 2 electrons over here to form a double bond, and that gives us this. Now, you may notice that why did I decide to put the electrons from this oxygen onto the double bond? I could have done it for this oxygen, and you'd be completely correct. And in fact, that's where our second resonance structure will come from. So what I can do is I can move this double bond back to form a lone pair on this oxygen, and then I can move a lone pair here to reform the double bond. And then we draw a double arrow, and we will see that we have this situation now. And now what you'll notice is that we have our 2 important resonance structures. There's nothing else that can really form because our fluorines cannot form any double bonds, and so therefore this will represent